Real quick review. We're going to start 15.5, the law of sines, and we're going to talk about what's called the ambiguous case today. But before we do that, I think it's good to review our unit circle values. So think about what's the sine of 30. Hopefully we can go quickly. It's 1/2. What's the sine of 150? 1/2. Remember, they both have 30-degree reference angles, so therefore the sine is positive in both the first and second quadrants. The sine of 45 would be square root of 2 over 2. The sine of 135 would also be square root of 2 over 2. Okay, so for time's sake of video getting too long, I took my first page of notes and I kind of already pre-did the work for you, but I want you to kind of notice some things. So if we look at this bell ringer continued, I reminded you of the law of sines, and down below we have the indicated measure on the triangle. It says, find it, but be sure that your measurement corresponds with the diagram. Angles that appear obtuse should have measurements larger than 90 degrees. Round all measurements to the nearest tenth. So in number 1, I had to use the law of sines. And when I did that, you can see that I got x equals 2.7. That seems conceivable to us geometrically because 81 degrees is larger than 42. So therefore, we know the side that's opposite 42 must be smaller than the side length of 4. And that ends up being true, so we feel good about that. When we look at number 2, we set up the law of sines again, and we're trying to find angle y. And when we do that, we get 25.4 degrees. And similar to number 1, geometrically, it still makes sense. Now, as we go down to number 3, I want you to really pay attention because this is kind of the key of the day. When we look at number 3 and we solve for a, the calculator gives us 48.5 degrees. But when you look at angle A, number 1, 40, it looks obtuse. And number 2, we know it has to be larger than 22. Well, 48.5 is larger, but the question is it the biggest angle, or could it potentially be the medium-sized angle? Because if we're going to go with 48.5, then that third angle is going to end up being larger than 90 degrees. It's going to be obtuse. So that means that third missing side is going to be the longest side. So we don't really know. Well, the directions said angles that appear, so we're going to go with 131.5 degrees. And the way that we got that, if you look at my triangles that I drew over to the side here, I have the green triangle, which is the calculator answer of 48.5. But remember, the sine is positive in both the first and second quadrants. So there should be an obtuse angle, 131.5 degrees, that also has the equivalent sine value. So because of the directions, we're going to use 131.5. And then the fourth one was just really quickly, I've done it in the past where it's just to see if you can quickly find angle B, and it's just the fact that 3 angles add up to 180. So the guiding question, how do you find an obtuse angle using the law of sines? And the answer is, you find the acute angle, using the inverse sine on the calculator. Then you find the supplement. In geometry, we learned that the ways to prove triangles congruent were angle, side angle, 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 side, angle, side, and side, side, side. However, side, side, side angle was not a valid way to prove triangles congruent. And the reason is that when side, side angle information is given, you could have potentially 2 triangles that satisfy that given information. We're going to investigate this below. The directions say solve the triangle and be sure that your measurement corresponds with the diagram. Angles that appear obtuse should have measurements larger than 90, so very similar to the previous page. So you're going to notice right off the bat that the information is exactly the same in both problems. So we're going to set up the list one on the left, the sine of 40 over 21, so G is 40. That side's 21, and H is 24. So we get the sine of H over 24, and we go ahead and multiply and solve. Now, for time's sake, I'm not going to go ahead and show all the work on how to solve it, but we're going to get H to be 47.3. I apologize for all these smears. Then we're going to go ahead, so we know this is 47.3. We can find the supplement, or excuse me, 47.3 plus 40, that together, and find the supplement of that to find this side, 92.7. And then we can say the sine of 40 over 21 equals the sine of 92. So we had the sine of 40 over 21 equals the sine of 92.7 over p. Again, we solve that. We're going to get 32.6. Now if we go down and do the same problem below, one thing that's going to start off to be the same is we know g is 40, and we know little g is 21, and we know this is 24. But the key is we're going to have basically some of the same work above. So rather than rewrite it, I'm just going to kind of highlight it. We would have this work to start off. But because P has to be obtuse, or excuse me, H has to be obtuse, we're going to make it 132.7 degrees. Then that's going to lead us to the other angle of P, which is 7.3 degrees. So then we can do the sine of 40 over 21 equals the sine of 7.3 over P. And again, doing the math, P equals 4.2. So here's a case when you look at these two triangles, same information, but drawing the picture differently creates two different triangles. That's why side-side angle is not a way to prove triangles congruent. So the given information is the same. Why are the solutions to the triangles different? Due to side-side angle, there are multiple triangles. Next guiding question. Which quadrants will the sine function output positive values? Well, we know quadrants 1 and 2. What angle measurements are associated? With 1, we have acute, and with 2, we have obtuse. How many degrees can you have a triangle? We have 180 degrees. Is it possible to have more than one obtuse triangle? No. So, the summary. When you're given a side-side angle case, this is what's known as the ambiguous case. One must check the possibility of two triangles existing. So therefore, here's what you need to do. Number 1, solve for the angle using law of sines. Number 2, see if the angle could be obtuse. Basically, does it make sense geometrically? If yes, find the supplement. And redraw the triangle with the given information. And number 3, if possible, solve both triangles. So we'll take you through some examples. All of these examples are going to start off side-side angle. So in number 1, to give you a picture, little a is 7, c is 122, and opposite c, little c, is 5. Now the first thing you set up is, does this make sense geometrically? Can 5 be the side opposite 122? And the answer is no, because opposite the longest side must be the largest angle, and vice versa. So this actually is going to have 0 triangles. 0 triangles work. So basically there's no solution to this triangle. Now, if you didn't recognize that and you set up the sine of A over 7 equals the sine of 122 over 5, if you solve this, what's going to happen is you're going to get the inverse sine of 7 times sine of 122 divided by 5. Well, inside the parentheses, to give you an idea, that's approximately 1.187. That's undefined. That doesn't work. We know that the sine value can only be 1 to negative 1. It can't be larger than 1. All right, number 2. If we set this one up, we get A is 45. 7 rad 2 is opposite it. B and C, and we have B is 7. So again, side-side angle given. Now if we look, we know 7 rad 2 is longer than 7. So if we look at angle A, which is 45, the first angle we'd have to solve for is B. So we would have the sine of B over 7 equals the sine of 45 over 7 rad 2. So I'm following our steps. We're using the law of sines to find the acute angle. So when we do this, we multiply through by 7. We're going to get the sine of B to equal 1/2. So we know B is equal to 30 degrees. Now the question here is, could angle B be obtuse? Because that's the next step. Could angle B geometrically be obtuse? And the answer is no, because B has to be smaller than angle A. So therefore there is no second triangle. We know there's one triangle. Angle B must be acute. Now, if we wanted to, once we did all this, for time's sake, I'm not going to do this, but we could go through here and find that's 30, and then we know this is 105, and then do the law of sines again, and basically you'd get this to be 13.5, but I'm not going to spend time doing that. Now we go on to example 3. If we draw this picture, little a is 10, little b is 8, and angle B is 36. Again, side-side angle. So we're going to solve by saying the sine of A over 10 equals the sine of 36 over 8. When we solve this, we get 47.3. Now, based on this picture, ask yourself, could angle A be obtuse? Well, if you look at opposite angle A, it's side 10. That's longer than 8. So the answer is yes. So at this point, what you want to do is I recommend drawing another triangle. Make A look obtuse. I wouldn't get too caught up with all the lengths, but making A look obtuse is key. B is still 36. This is still 8, and little a is still 10. But the point is, we want to find the supplement. We want to take 180 minus 47.3. That's that first quadrant angle. And we want to come down here and say this is 132.7. So then at that point, you could solve the rest of the problem. As you can see, I've shown you the work on the paper to find the different side lengths. But the key to the whole problem is the 132.7 that you found, and then basically it becomes two triangles, and you solve each one like we did the previous day. So good luck.